All right, so welcome everybody. Today we are going to have our lecture 3, take a break, and then we will do our lecture 4. And so today's first topic is going to be variables and programs. So let me go ahead and share the screen. You know the routine. If you wish to follow along, you can either choose to, oh, can you see that? Yes. Okay. You can either choose to follow along with us on the Zoom, or you may download the slides from the lecture. All right, can you guys see that? I usually get a green box showing what it's sharing. Yes, you see. Okay, great. And so, for some reason, let's do this. Ta-da! All right. So our bird's eye overview, we'll talk about the concept of overloading in Python, which is something that's going to come up over and over again. The next thing we'll talk about is variables, which you're probably already familiar with from math. So we'll see how those work out in Python. We'll talk about writing programs. We will look at the print statements, and we will also talk about comments. And by that, I don't mean chatting. I mean actually making comments in your programs. Alrighty, so then I thought, would you like to change the slide? There we go. All right, overloading. So overloading is the idea where you may have more than one thing working with the same operator. So let's just consider we have different but conceptually related operations given the same notation. So from math, we have this concept of operators. Now, operators is a fancy way of basically saying like plus, minus, multiplication, division, checking to see if something's less than something else. It's basically some kind of a sign, say like in math, that causes some action to happen. So for example, 2.5 plus 3.5, the operator here is plus, which is adding the things together. So we have talked about working with adding floats and, for example, integers. So because the plus sign does the same thing, what that means is that it's overloaded. We say that it's overloaded to do addition on two different types. Now, this may start to get to be a little bit picky because we're saying, well, plus is plus, right? What's the big deal? Well, the big deal is about the types in Python. And we've kind of already started to see this last time when we were talking about, how many decimal places will this have and what will be the type of doing a particular operation. And so what we saw is the division always changes to a float no matter what. And so what's really going on under the hood is that Python is actually having very important information about whether you're working with a float or whether you're working with an integer. And that may not seem that important because at the end of the day, you just added it together or whatever. But the reason why we're thinking about this is because we need to start thinking, again, like computer scientists, we need to think about what code caused this to happen. And is it the same actual block of code inside of Python that's causing these to happen? And the answer is actually it's not. And that's why this starts to get to be important, because suppose something goes wrong, or suppose you want to purposely cause something to behave a particular way, right? So what we want to do is we want to be cognizant of what types are being used and which operator is being used. And this idea of having the same operator do similar but different things is what the idea about overloading is. And we will see some very clear examples of that coming up. So as we have been saying, under the hood, these are really different operations, even though they may look like the same sign. So we look at plus and it innocently looks the same all the time. But what we're saying is that a different block of code may be executing. And so if there's a problem, it's quite possible that we need to differentiate which block of code is actually doing the plussing. So the types are what is used to tell the different ones apart so that the operator then works from a particular piece of code. And so as expressions get more and more complicated, it becomes increasingly important to keep track of the types of what it is that you are using. And that is a theme throughout Python. So we've kind of already seen strings, but let's just talk about this in a little bit more detail here. So just as a quick recap, there are a sequence of characters that is text. And so to enter a string, we would be putting either double quotes or single quotes, and strings have the type str. Okay, great. We already learned that. So what's new here? This is the overloading, the plus. And the reason why I have these dashes here is not because you should actually type them, but it is necessary when you use an operator to put some space. You need to somehow tell Python what's what. So we're just doing that to show that there's a space there. So the plus in Python is overloaded to do string concatenation. So obviously you wouldn't expect to do like pi plus thon to give a numeric answer. So obviously the same thing that is happening with, for example, adding two floats is not happening here. So what it's doing, as we see over here, is it's doing what we call concatenation. That is bringing the string together. And how that happened is there is actually a piece of code in Python that says, what should I do if I have a type string and another type string with the operator plus in between? What should I do? And it's defined to be the string concatenation, and you will learn how to write your own thing to concatenate stuff. But anyways, the idea here is that the plus is obviously doing something different than it did before. And also we have the multiplication symbol, which is being shown here as the star. This is the star that is shift number 8 on your keyboard. And this will cause string repetition, which maybe you expected or maybe not, but that's what will happen in Python. Again, this is a really great example of how we can use the interactive interpreter to find out what will happen rather than write a whole script for this and then look at that later. You can just do it interactively and be like, oh yeah, that's what it does. So here are some examples showing overloading of plus for strings. So here we have some variables, and we have a greeting here, right? And we have concatenation happening on here. So we can write the secret message, have a great day. We also have 3 distinct uses of pluses. Here is integers, here is floats, and here is concatenation. Notice here that these are numeric, but why are they not being treated as numbers? You might have expected the answer to be 7. The reason is because of the type. And so we see that these quotes here are indicating that these should be treated as strings, which could be any text, including the digit 3 and the digit 4. And that's why that comes out 34. And that's how you can add 3 plus 4 and get 34, not 7. All right, next up is variables. So variables are names that refer to values. The rules for variable names are they may contain only letters, digits, and underscores. You may not begin with the digit, and this has to do with how Python is going to figure out what it is. So you may not begin a variable name with a digit. You can have a digit in it, but just not in the first position. They are case sensitive, so they're distinct between the different ones. You should not be any of Python's keywords. Yeah. So there is a comprehensive list in your book, and we don't necessarily expect you to sit there and to memorize them. So from a practical standpoint, there's a couple of things you should keep track of here. So the keywords that we've learned, I expect you're not going to set them up as a variable, okay? Because that would be a bad idea, and I'll show you why in a second. And suppose you didn't know it. Maybe there's a keyword you don't know yet. And so how will you tell? Well, Python is helping you to know that because it's turning them a special color, okay? So let's see what some student, now you would never do this, but let's see, some student might try this. So here we have print equals 1. Now, let us recall that we have seen print, and that print does something like print something onto the screen, okay? So here we have taken the keyword print and we have reassigned it to have the value of 1. We say, Python, what is print? And it says, oh, it's 1. Okay, now we come along and we want to actually print hello. So we go print hello, and look what happens. We get an error. Why did that happen? Because print used to be the Python keyword to run the code to actually display something on the screen, and it's been overwritten by the number 1. And now we try to access print, and so this basically is parsing to 1 of hello, which makes no sense, and that's why we get an error message. So while it is possible to do many things in Python, sometimes it's not a good idea to choose to do that. And that's a prime example of why we should be careful about what we name our variables. All right, so here's some examples of variable assignments. A equals 2, this says the variable called A is assigned integer value of 2. Here B is being assigned a float 2.0. C is being assigned a string called cat, and D is being assigned the Boolean false. So notice the variables can take on a variety of different types, and basically their type will be whatever the type of their value is equal to. So in variable assignment, an assignment statement causes a variable to refer to the value of a particular expression. The value of the variable becomes that of the expression assigned to it, which we just said. So although we use the equal sign to do the variable assignment, a better way to think about this is takes the value of or gets the value of. So really we should be looking at it like this. Variable takes the value of whatever this expression evaluates to. So for example, A gets the value of the integer 5. So the variable assignment has a 2-step process. The expression at the right is evaluated to a value, because notice I mentioned that it gets whatever the expression resolves to. And so that's why we need to actually evaluate the expression to figure out what it equals. And then step 2, the value that it got equal to is assigned to the variable on the left. So let's take a look at a simple example. Here's a variable x equals 1 plus 1. So what's really happening here is in the first step, we're evaluating the right-hand side of this expression. And so 1 plus 1 is going to be equal to 2. So now we have x equals 2. Then in step 2, we actually assign the value of 2 to x. So x never actually knows what this expression looks like. X only gets the value of whatever the expression resolves to. All right, so now this is your turn. Variable assignment, x equals 2, x equals x plus 3. Explain the 2-step variable assignment process and what will be the value of x. All right, would anybody like to give this a try? All right, go ahead.
So x is 2, so then that's what it says in the first line. So then in the second line, you have to plug in 2 to x, and then 2 plus 3 equals 5, so x equals 5.
Right, yes. All right, very good. And so that's basically it. Any questions from anybody on how to do this? Notice that this is very different than something that looks very similar that you may have done in algebra, right? So imagine that you're in algebra class and you get x equals x plus 3. What you might have learned how to do is to move all the variables to one side and solve for x, right? So you might subtract x from both sides and get 0 equals 0 plus 3, and therefore 3 equals 0. Right? And then you'd be scratching your head and saying, I wonder what that means, right? So in computer science, it doesn't mean the same thing. That's not the same thing as a math expression where you solve for x. And the key to getting this is really just understanding that we say x gets the value of whatever the expression is. And as Gabriela has illustrated here, we have to evaluate that expression to get the value of it. And then whatever that resolves to, in this case 5, gets assigned to x, which is quite different from algebra. Questions?
I have a question.
Yeah.
Okay, so you said x equals 2. So why didn't the, I guess, assignment of x persist into the next equation?
But
why wasn't it?
That's a good question. All right. So you have to remember that Python doesn't think like humans think, right? It's going to have algorithmic thinking. And the rule says it will evaluate the expression on the right first. So the value of x, the current value of x is 2. Do you agree?
Yes.
Okay, the current value of x is 2 plus 3 will be 5. And now we are overwriting the current value of x to be 5. So you
it's like
see,
a reassignment?
yes, you got
Okay.
it. Yes. So that's the confusing thing about this, right? Because you can get caught up in this. There is a wonderful exercise on exactly this that we do in the regular lab. I think it is actually in your lab too. And I give it to students and they're like, oh, that's really weird, because you ask Python to tell, what is the value of X, and, you write it out stepwise and it seems so obvious. And I put it on the exam, and every year about 10% of the class gets it wrong, because they don't do algorithmic thinking. You have to follow the steps, right? Python says, this is how I will solve this problem. And it does exactly that. And so you have to put on your algorithmic thinking cap. All right, is that clear? Better?
Yeah, thank you.
Yeah, good question. I'm glad you asked. All right, and this is our solution. So we have basically already hashed through this. All right, great. So the next thing we're going to talk about is the variable tables, which is very much related to what we have just been saying, because what we are talking about here is actually writing down the current value of each of the variables that exists in the Python world. So when you are running a script or when you are typing interactively, there is such a thing exists in Python that there are some certain variables that are defined, right? So there's always the ones that are defined in Python, but as you are creating variables, then those variables come into existence into Python. And so this is what the variable table is for. Now, does the variable table exist as a little chart in Python? Well, not exactly, right? It's more like the values that are active in Python. But as humans, it's very useful for us to actually write a little table, and that's what we have over here. So this is also known as the environment or a state diagram. It's just other words you may come across if you do some reading. So it's important to keep track of the value assigned to each variable and also which variables have been defined. So you're going to assign a value to a new variable, and that will cause it to be added to the variable table. Reassigning a different value to an existing variable causes its table entry to be overwritten, which is exactly what we were just seeing in the last example. It's an error to refer to a variable that has not yet been assigned a value. Common mistake that may happen, you may call a variable that doesn't exist yet and you'll get an error because it has no value assigned to it. As Python runs a program that repeatedly consults and updates this variable table to keep track of the program's state. So here is an example of a variable table where W has the value of the string hello, X has the value of the integer 42, Y has the value of 3.14, a float, and Z has a Boolean value true. All right, and so now we might want to put all these things together into some programs. That would be much more interesting. All right, so what do you think a program is? I mean, you kind of talk about programs these days, maybe even you kind of call it an app. Put an app on my phone or, runs a desktop application. Well, really what we're talking about is all the same thing. What do you think constitutes a Python program? Maybe we could hear from somebody we haven't heard from yet this morning. Anna, do you have any thoughts on that?
Maybe like something that creates like an action or something.
That's a really good way to think about a program. Let me challenge you with this. Do you think it's possible to have a program that does nothing? It would
maybe.
be a silly one. we could write a program that does nothing. But yes, in most cases, we want to write a program that causes some action. And how we could term that as a computer scientist is we might say that it causes an action in the environment, or it causes an effect on the environment in which it operates. In a sense, a program could be considered an operator, just a very big one. All right, let's take a look and see a more formal definition. Thank you for sharing. A Python program is a sequence of statements. That's a formal definition. We can save a program to a plain text script file to edit or run later, which you have seen last time. We'll use Python's built-in program editor called idle for writing Python, which you have already started. Python script should have the suffix .py, and running a program causes its statements to be executed in order, which by that we colloquially mean from start to finish, top to bottom, but we will soon learn how to manipulate where that imaginary pointer is going to go to a different place. So we may have if and else and all these other things. And in fact, we call that the flow control. That's the title of that lecture, flow control. So unlike interactive interpreter, running a program for the file does not cause the value of every expression to be displayed. This is an important point that oftentimes confuses people, because when you work interactively and you type something, immediately you see the answer. But if you want to see it when you are running a program from in the script, it is important that we are going to need to explicitly tell Python to print it out. Now, just because it's not printed doesn't mean that it doesn't exist. So for example, here is just a little simple x equals 2, y equals 3, and then x plus y, right? So that expression gives the number 5. And so Python will in fact compute the number 5, but if this is in a script, you will never see it. So you'll never know whether Python did it or not. I mean, we know it because we made the computers, but we'd never be able to see it. So what do we need? Well, as you may be suspecting, that is why we have print statements. So print statements cause a textual representation of whatever they're printing to appear on the screen. Print will print the resolved value of what it is printing. So if you give it an expression as something to operate on, it will resolve that expression and it will cause the result of that expression to be printed. It itself is actually not a statement, but it is a built-in Python function. We'll talk about functions shortly, but basically it's one of those things in Python that's causing some stuff to happen. It's a built-in function, is what it is. Print only displays strings. Now, you may be a bit puzzled by that statement, and you should be, because that would mean we could never print a number, and actually we can. So how does that work? So numbers will automatically be converted to strings when they are printed. And we will talk more about this, about coercion, coming up. So here's a syntax for printing. We would have the keyword print, which is the name of the function. We have our mandatory parentheses, and we fill in something inside of this bracket. Recall that you would need to have parentheses, quotes on the things that are to be strings. So here's a series of examples of how you can print something. Here we are printing this quote, the answer to life in the universe and everything is, and it's verbatim, prints out whatever is in the quotes. You can also print some more text. You can print a number. So here's an example of printing the digit 5. Note that it's in quotes, so it is in fact already a string. Suppose we want to print the value of a variable. So here is a sum of some numbers, and we could print the answer, and it gives us 42. Notice that this did not have quotes around it. This is what we are saying about converting to a string. It did it automatically all by itself to help us out. And so what we have here is that it resolves the expression to 42, and it prints the answer just like that. We could, so in this case, we have answer as the variable, and we get the answer being stored in answer, and then we are printing answer. Here is a variant of that where the expression is directly the thing that the print is actually printing, which is distinct from storing it into a variable and then printing the value of the variable. This just prints the value of the expression directly. We could print some text and the value of a variable. So notice that what we have here is a string, and then we have a comma here, and now we have a variable. So when we print this out, it appears just like this. It prints the thing here, and then it concatenates that with a space in between with 42. We can also print using concatenation explicitly. Here we have several strings, 4 to be exact. Notice that when we print with concatenation that there are no spaces in between, so you would need to actually put a space. Like if you wanted to have a space there, you could leave a space in the quote, for example, or you could plus a space, but this is what you'll get. Okay. Incidentally, this is from a sci-fi comedy, The Hitchhiker's Guide to the Galaxy, which you may or may not be familiar with, but if you're looking for some fun reading on the side, it's a kind of a nerd joke, and you can enjoy that in your spare time. All right, so one other thing that I wanted to talk to you about is comments, and I don't mean chatting with each other, I mean comments for your code. So a comment is text in a program that is intended for humans and not computers. The benefit of the comments is that you can leave some information for your future self or for someone else who may run your program. And also it can be useful to you as you run programs that others have written. So comments are ignored when the program is run, and that is by Python, we mean. In Python's comments can start with the # symbol and go to the end of the line. So here we have a very enthusiastic student writing print. Programming is fun. And they said, yes, it is. I love programming. There is an alternate style of commenting that uses the triple quotes. This works by extending the commented block over multiple lines. So here we have the triple quotes at the beginning and the end. It can also be that the triple quotes are in line with the text, so it's not necessary for them to be on separate lines. I mean, this is kind of just a stylistic thing. And as you start to look at some of the coding examples and so on that I will be showing you, I do tend to like to do the triple quotes that way. It's very useful, and it allows you to do things such as put headers on your papers. So as I was saying, comments are very useful. There's a number of things we can use them for. You can put them on your assignments, so that's probably the first time you'll see them. You can use it to explain some code. Maybe you wrote something and it's not obvious, or you're afraid you'll forget, or maybe you need to put a note to yourself like, I need to check this when I work on this tonight. You can set up the code outline before you fill it in. And also, this is extremely useful for debugging code because it enables you to turn on and off segments of your code. Here are a few tips for using comments by example. Here's a comment in triple single quotes. So notice that you can also use the single quotes as the triple quote. Here's a comment that's in triple double quotes. Looks like this. Commenting by a line is achieved by using a pound symbol, and that goes all the way to the end of the line. But when you want to start the next line, and you want it to be a comment, you got to do the pound symbol again. So you can comment by a line using the pound symbol. Now, when you put the pound symbol, it's going to comment everything to the right of it. So if it's the beginning of the line, that means the entire line will be commented. But you could put it in the middle of a line, and then it will comment to the right. And notice how the coloring is occurring here. This is cluing you in that it's different than the other part. Right? So this purpley fuchsia color is for Python keywords, particularly functions. Green is going to be for the strings. Black is going to be for stuff that's not that. The red is going to be for things that are commented by this method. Mixed quotes do not work for commenting. So if we try to comment with double, double, single, single, double, double, that's not going to work. The reason why this one is commented is because the pound symbol was there. Here's an example of blocking off a whole section. To have quotes inside of a quote, see how we have this string in here, and notice this has a quote. You have to use different quote styles. So for example, if you had chosen to use the single triple quotes, it would read, Python would read, open quote, open quote, open quote, close quote, close quote, close quote. And so you'll see that the commenting would be over midline, and we can introduce all kinds of problems when we do that. So generally, a stylistic choice that I prefer to make is to use the triple double quotes. And when I want to have a string, I will use the single quotes. Now, you don't have to do that, but it is a useful convention and helps not create some problems that could happen if you are going to have blocks. Okay, the quotes can easily be removed from the above block to uncomment the code. So notice that that is a strategy that could be used in order to debug some code. Maybe I wanted to turn this section off for a little while because I'm working on something else, and then I want to turn it back on. I can do it by adding the triple quotes and deleting the triple quotes. Notice that you need to do the beginning and end triple quotes all together as one block. Otherwise, you will cause some problems. Comments in your submissions. Every script file you turn in should begin with a comment containing your name, your email, course number, lab section, assignment name and number, and the date. Something like this is what should be at the top of your papers. This is an example of using comments in Python. So let's take a look at this. What are different uses of comments in this code snippet? All right, so we've talked about a number of different things we could do. And I know that you may not know everything that's going on in that. And that's okay. That's part of what we're doing in the code reading part of the class. So maybe we could hear from somebody we have not heard from yet this morning. Would you like to point out a place where you see comments being used and tell us what you think is happening? If you don't know what is happening, that's okay. That's what we're here for.
In the very first line, there's the triple quotation marks, and then it also ends a few lines later. And I think that's just kind of like introducing what's going to be like shown here in this file.
Yep, it is the header. Excellent, thank you. All right. Jayden, do you see any other use of comments in here?
Yeah, right after the definition function, there's another triple quote, and there's another triple quote. I don't know if, just comments. I thought you were just commenting out actual code, but it doesn't look that way.
Yeah. Okay. Yes, you're very astute about this, and so in fact it is a comment, and it is a comment on a function, and we haven't talked about functions yet, but just to give you a preview of what it does, functions are basically a block of code that can execute independently, and so then what we can do is we can call that function to do a particular job. And so whenever we have a function, what we want to do is document what it's doing. And that's what this is doing. It's telling the types of the input and output of this function and some other things that have to exist. And then it's telling what it does, so that when somebody looks at this, they can look at it and be like, oh yeah, so this is supposed to return the non-negative index of the first occurrence of a character in a string. Whatever, why one specifically wants to do that, I don't know. Maybe the homework said to do it, or maybe, I don't know, maybe you're solving a cipher. Oh, actually it is. Yeah, it's the Caesar cipher. That's why you're looking for that one. Okay, and you see here's another example of a similar use down here where we're explaining what the inputs and output types are, what has to be true about the input and output, and a quick little note about what's happening. And then we see also that some additional information is being provided. This is also a useful instance of some commenting. You see that somebody was in the middle of doing it. In fact, actually, this is the starter file. So this is the assignment file. So when I give you an assignment to do, I might give you some of the code and then you need to do the rest of it. And the reason why there's a comment here is because I'm telling the students, this is where you have to do the work. You should write something in here, and we'll see about pass in the future. That's basically a place filler. but you can look at some code and you can understand where the comments are and get some idea as to what they are being used for. All right, you guys are so good. Okay. So here's some code reading and debugging. This is a bit of an easier bit of code, and I'm a bit famous for this. You see the fly I have up here. So we have these on the test too. These are the debugging one. And so just as a historical note, does anybody actually know why it's called a bug in the code? Everybody knows what it is, right? It means the code doesn't work. Well, back in the olden days, there was this thing called punch cards.
I think I remember this story. I think.
Go ahead. Do you remember?
Oh, sorry. Yeah, I think it was about this person, and I know it was a she. I think it was a she. She did something. She was coding, and so I think something wasn't working right. And I think when she opened, like, I don't know if it was a computer or something, there was a bug inside, and so that's why debugging came. I don't know if I got the story right, but
yeah, you're very close.
It was because there was a bug in something that was preventing the machine or something to not work, and so that's what caused the machine not to work, and that's where debugging came from, I think.
Yes, that's exactly the story. In the olden days, people would not type their Python code on a computer. They would actually have to make the punch cards, because the computers would actually read the ones and zeros off the punch card. Now, of course, we have compilers to handle those things. And Python is not exactly a compiled language, but we have something similar as to a compiler. So we don't do the cards anymore. And I actually have one. I'm going to have to look and see if I can find that. I have a Fortran punch card. But when you have the punch card, it just punches out these little like rectangles, and they're kind of small. So if a fly flew in there and got squished on the card, the machine could make a mistake that it was in fact not punched. And that's what had happened. A bug had gotten stuck inside and got squished on the card. And so when the card went through, the code didn't work because it was supposed to be punched there, which the user thought it had been, but the machine saw it and it was not. And so back to the drawing board to make a new punch card. And that is where the name of it came from. Fun story. All right. So I'm a bit famous for giving out buggy code. As a matter of fact, we have a whole lab that's only on this problem. And so one of the things that's very useful to get good at is identifying where the problems in your code lie and being able to remove them. So when you see this fly on the slide or on your assignment or on your test, you can be sure that there's some code that may or may not be working as expected. And so let us take a look at this example here. So what we got here is debugme.py. One tile is 3 by 5 and the floor is 7 tiles by 8 tiles, right? So the idea here is we're thinking about tiling a floor. And we're going to compute the area. So you may remember the area is computed as length times width. And we're basically doing this in blocks of 3 by 5. So here's a snippet of code that is not computing the area correctly. What output do you expect? Try to run it and compare with your expectation. And then we can use commenting to stop the program from trying to print the area while you're searching for the problem. Introduce print statements to check the values of X and Y and verify they are as expected. This is a very powerful way to debug things, is to put print statements in, because we want to say, well, Python, I thought you thought, this, and Python may not agree, okay? And so if we don't ask Python in the intermediate, Python is going on its merry way, doing its thing, and it may not be what is expected. And by printing it, that can identify some things. So here is some code, may not be working. We're supposed to be calculating the volume. we're going to introduce a working variable assignment and turn the area print statement back on by uncommenting it and successfully executing the code. All right, so we're doing pretty okay on time here. Shall we just pause for a moment and you could actually try this out? All right, why don't you take a moment? You can actually try typing it in and see if this actually is going to work. And then you may notice that when you run the script, it's a little bit unexpected. So if the one tile is 3 by 5 and the floor tile is 7 by 8, right? We would just get the area of the floor by multiplying the size of the tiles times the number of tiles, right? Should be a fairly straightforward one to calculate. All right, let's give it 2 minutes. All right, see, type it in, try it out, and see if you can identify what is wrong here. Who can spot the bug? Oops, sorry. Alrighty. Ideas about this. First thing, tell me, what happened when you tried to run the code as written? Did it work? I don't think so. What outcome did you get? Okay, looking at this right here, right? X times Y. The X times Y, right? Now this right here, tell me, what is the type of this? Did you get a chance to try it out?
A string.
It's a string. And what happens when you have a string times something? A number, for example.
It's going to print the string that many times.
That's right. And that is definitely not what we were trying to do. So the bug in the code is then what?
The quotes.
You got it. That's what you have to do. So just by simply removing the quotes, you can fix the problem. And so that is what is being shown here. right? So all we have to do is, oops, get rid of that. And ta-da, now it is going to work. So one of the ways you can do it is you can print out the various parts. You can try running the code, and all of those things will help you to see that it's not behaving as expected to compute volume. And then we can do this. And ta-da, it multiplies the numbers together so that we can get our volume.
I have a question.
Yes, please.
How do you edit on Python? Because I always have to redo the code. I'm not really sure how to do
Are you doing it interactively, perhaps?
I'm doing it through the website you had us download it.
Okay. I think that the issue may be that you're not typing it in the correct place. Would you like to show me your screen and how you are trying to edit your code?
Sure.
All right, let's take a look. We're actually basically done with today anyways. All right, so I'm actually gonna just stop the recording. And let's see. All right, so now I see, yes. The reason why you cannot edit is because you are doing it interactively, okay? So may I suggest you go to File, New File, up at the top, way up, there you go. Yeah, File, New File. Ta-da, okay. Now what you can do is you can put it in there and then you can run it. So then you can edit it and redo it as many times as you like. All right, so of course we're gonna need to delete the chevrons because those are not Python code. But other than that, it should be good to go.
Okay, thank you.
Yeah, you're welcome. It's just a matter of where you type it, that's all. All right, but you know what I mean when I say to delete the chevrons?
No.
Okay, it's those, it's the prompt, the 3 greater than signs.
Oh, okay.
All right, yeah, so you just delete those so that it begins at the left.
Okay.